Alright, geometry. Since I'm going to be gone on Friday, I thought I would try doing a flipped classroom lesson with you guys. Since there's going to be a sub on Friday, and thought this would be, since it's the start of a unit, this would be maybe a good time to try this and see how you guys like it. Alright, so the first unit in Chapter 4 is about congruent figures, sort of defining what congruent figures are, and saying, well, what do you know if you know that you have congruent figures? So, first of all, here's some pictures of our friend Phineas here, and the ones I've shown you here are all what we would call congruent figures. They're all congruent drawings or geometric figures of the same size and shape. So if we were going to measure this little angle right here, it would be the same. It would be the same angle as if we were going to measure the angle right here, the angle of his nose right here. If we're going to measure his height over here, it would be the same here and be the same here. Those parts that I keep talking about, like the nose angle or the height or the total area or anything like that, those are what we call corresponding parts. This point here corresponds with this point here, corresponds with this point here. And that's really the crux of the whole lesson. It's really kind of the main idea. Sorry, I keep messing with my tools here. Just a second. Alright, this document you see here, this is the notes for 4.1. It is already loaded up on Blackboard, so you could be looking at this as you go through, or you'll see it when you get to class. Okay, so these are what congruent figures might look like. And notice, to get from this one to this one, all I did was spin him around. That's okay. But from this one to this one, I actually also flipped him over. I flipped him sort of backwards, so he's pointing the other direction. And then also spun him a bit. So that's okay. So it doesn't really matter what direction things are pointing. They can be flipped over, they can be spun, and they'd still be the same. We call them the same size and shape, even if they're backwards. This is not cool. Notice who I picked for these, the not congruent things. None of these three things is congruent with any of the rest. Here, obviously, he got smaller. Here, he didn't get any shorter from the original, but he got a lot wider. So that messes with the angles. Some of the distances might be the same as some of these, like the height, of course, is the same. But like the length of this foot, notice, is a lot longer here. That's not good. Here, if you look at like the angle of the knee here and the angle of the knee here, those probably look the same. I think all the angles in this one are the same as this one, but that doesn't mean they're congruent. There's another word for this relationship. There's actually a different word for this relationship too, between these two things, but we won't get to that this chapter. This chapter is all about congruent, very straightforward. Everything is the same size and the same shape. So all the angles are the same, all the lengths are the same. And there you go. Points that, here's the way I say it a little better. Points that do the same job, whoops, sorry about that. Points that do the same, I want that to go away. It's just getting worse. Alright, points that do the same job in different figures are called corresponding points. Sort of like our recent chapter on angles. We had corresponding angles. Here, let's try the drawing. Woot, woot, woot. We had corresponding angles, which are angles like this and this. They kind of did the same job at two different places. And when those lines were parallel, those angles actually turned out to have the same measure. This is a little more involved in that. This is, okay, if I know this whole triangle is congruent to this whole triangle in this fashion, notice it says triangle ABC is congruent to, we're familiar with this symbol now, triangle XYZ. If I say it that way, A and X go together, the way this statement is working. B and Y go together. C and Z go together. I can be very sure about how those are paired up without even looking at this picture. I know that anything that happens at A has to be the same at X. In other words, angle A would have to be the same as angle X. If I look up here, the angle at A, 50.61, the angle at X, 50.61. I did these in Sketchpad, by the way, so I know they're perfectly congruent. B corresponds to Y, so angle B, which is this one, 107, angle Y. Angle B, angle Y, see that? Angle Y is 107, and the other ones are the same. These distances, the distance from A to B, it's the first 2 points here, would be the same as the distance from X to Y, those 2 points there. A to B, 1.93, X to Y, 1.93. And they're all like that. So the way this statement is written is very powerful, but because of that, you have to be very careful about it. I couldn't say triangle ABC, like this would not be good. Triangle ABC is congruent to, and just go, oh yeah, it's this triangle over here with an X and a Y and a Z in it, and go X, Y, Z, like this. Like, you can't do that. That won't work. That tells the reader that A in one triangle is doing the same job, has the same angle, has the same congruent segment connections as Z in the other triangle, and that's simply not true. A over here and Z over here, no, that's not the same thing. So I can't. That would be crazy talk. I can't say that. if I wanted to talk about ZYX, just to make life interesting, because I already talked about ABC up here. If I want to talk about ZYX and say what triangle is congruent to ZYX, I can't say ABC. I have to say, well, Z goes with, and I got to be careful that the letter in the first spot is the right one over here. Z has to go with, looks like C, and Y has to go with B, and X has to go with A. So again, I have to pair these up correctly. And notice the pairing in here is the same as the original pairing that was correct here. That A goes with X, yep, A still goes with X, it's the third one now. B goes with Y, B goes with Y, and C goes with Z, C goes with Z, so that's still fine. So you have to be really careful that when you line these up, you got to make sure that this lines up in the same way. I can name the first triangle kind of however I want, but once I've done that, I got to make sure that the second one agrees with that. Actually, that wasn't terrible to erase. I could leave that in there. Whoops. Oh, really? One at a time? Okay. Right. So, yeah, and here I said make another one. I actually did that already up here. You can make your own. Don't do CBA. I'll know you cheated. Okay. But this doesn't work for just triangles. By saying I got a triangle congruent to a triangle, that automatically gives me all these things that are congruent. I would have, like I know that AB would be the same as XY. I know that BC is the same as YZ, and I know that the other segment is congruent also. I also have these three angles are going to be congruent to these three angles. So that's a total of 6 what we call parts that are congruent. I've got 6, all of a sudden 6 things I can really prove just by knowing this fact. It's kind of a big deal. This triangle congruence lets me then in a proof say, well, okay, if you know if this is true, if this is congruent, how do you know, say that AB then is congruent to, I'm just looking up here, AB is congruent to XY? Well, the reason is because I know that they are corresponding parts that belong to these congruent triangles. And that's kind of the whole, like I've been saying, that's kind of the whole point of this whole section. And how do we say that? Okay, pretend we're in a proof, and that's a step. The part that goes with this on this part of the proof, we would say corresponding parts of congruent triangles. That makes sense? Corresponding parts of congruent triangles. This is a very popular proof reason. CPCT. It's about as popular as transitive. It's all over the place. And of course it's going to be all over this section and all over this chapter. So, yeah, I said it down here. It's called CPCT when you've got corresponding parts of congruent triangles. And it's quite useful for lots of things. I mean, like I've been saying, if you've got just one triangle congruent to another, bang, you get six sort of facts for free that come from that. That's more than, you know, most theorems. Okay. It's also true for bigger polygons. If you had this, what was this, a hexagon? Hexagon congruent to this hexagon, and I know, and we talked about this last chapter right at the end, if I could name this A, B, C, D, E, F, I could say it's congruent, or if I knew it was congruent to G, H, J, K, L, M, I could say it that way, or I could say it this way too. I have to be careful. If I called it C, sort of starting this way and going like that, I'd have to start at J. If C really does line up with J, and these are kind of going in the same direction in terms of congruence, I could call that J, H, G, M, L, K, like that. But I couldn't do this. This would not work. B, A, F, E, like that. I couldn't say that lines up with K, L, like it looks like it goes, well, first of all, it goes the wrong way in terms of how it does the same jobs as this one. But the points just aren't lined up. Like the first point over here is B. If that one's really supposed to be congruent, I mean, if we believe this one says that B goes with H. I can't later then say B goes with K. Like it just doesn't work out. There might be one or two that do line up here, but it's not that. This is not an equivalent statement to this. If you had regular polygons, I guess they'd probably both be true, but they aren't here. It could have been, remember Phineas here, when Phineas was sort of upside down. Let's put Phineas in a box. Let's put him in a quadrilateral. And so it was there to sort of foot. If these are actually congruent figures, I could say, let's call this A, B, C, D. And let's call this, oh, this will be fun. Oh, I was going to spell verb, but I have a B here. I can't do that. W, X, Y, Z. Make the congruent statement that is true between these two quadrilaterals. Well, I'm going to call this one ABCD just because, you know, that would be obvious to call it that. Now, but when I go to make this one, I got to be careful that the point that I list first here has to be the same thing as what A is doing over here, which was tip of the nose, so that's W. Then B goes with back of the head. Oh, back of the head over here is Z, so it's not obvious. Then ABC, the third letter here was sort of the heel one, which would be Y. And actually, once I go WZ, I kind of know it's going to have to go, you know, around this way. WZYX. I picked this because, look, ABCD here was a sort of a clockwise naming scheme, and notice how WZYX here is kind of a counterclockwise naming scheme. That's okay. That happens here because when I went from this one to this one, I kind of did some flipping, and this one is actually a rotation, but also a mirror image of this one. So when I go to do the naming and make the corresponding congruence thing, that can happen, and that's okay. I think if I made a congruent statement about, and by the way, this is called the congruent statement. The congruent statement between this one and this one, I think it would probably go in the same kind of clockwise order. I'm just guessing. Let's call this P, Q, R, S. And if these are really congruent, let's compare ABCD with P, Q. Whoa, what happened there? ABCD, whoa, I lost my pen. Just because I made a mistake. ABCD with this one. Well, A was the tip of the nose, so here that's P. B was the back of the head, so that's Q. Looks like I'm going to go PQRS, actually. Yep. RS. And this, remember this naming scheme, A to B to C to D was kind of a clockwise thing, and P to Q to R to S, it's also a clockwise thing. So my point is, it doesn't matter. What does matter is that A and 1 has to be, you know, like which was nose tip, has to be nose tip, and back of the head has to be back of the head, and heel has to be with heel, and toe has to be with toe. All right, great. This is really as easy as it seems by this point. Okay, have I said everything? Yeah, here's the 6 congruence statements you get to make after, you know, triangles are congruent by CPCT. Notice the T in CPCT stands for triangle. Our book just sort of wimps out and they say, well, this whole idea of, okay, you got these 2 things that are congruent, therefore you get to sort of bleed these 6 truths right out of the triangles congruent. That only seems to have a name for congruent triangles. There's no reason why they couldn't have said, well, I know on this one that angle, if these are really congruent, if you can believe that say angle A is congruent to angle G because they're corresponding parts of congruent hexagons, but they don't have a CPCH. If you did that in a proof, I wouldn't care. I would let you do that. That would be fine. But just notice in the book, all the proofs they give you, you're only going to have to say it for triangles, which makes it a little bit easier. Okay, great. Be nice to the substitute. I will see you next week. Good luck with the homework in class.